Okay, let's dive right into this explainer. Today, we're uncovering a high-stakes scientific rescue mission involving one of the world's rarest and, quite frankly, most sought-after medicinal plants. We're looking at a fascinating story where ancient medicine collides head-on with modern biotechnology. It's a literal race against time, and we're going to see how a clever botanical hack might just save an entire species from total eradication.
0.2%. I really want you to let that number sink in for a second. 0.2%. That is an unbelievably low natural germination rate, and it perfectly sets the stage for the massive biological crisis we're about to explore. I mean, when a species can barely reproduce on its own in the wild, any external pressure is going to trigger a rapid, dangerous downward spiral.
Section 1. The Healing Orchid of the Hindu Kush Himalayas. Let's head up into the mountains and meet our subject.
So, we're traveling to the extreme subalpine and alpine zones of the Hindu Kush Himalayas. It's an absolutely unforgiving environment, sitting anywhere from 2,800 to 4,200 meters above sea level. And surviving up there is this beautifully vibrant purplish lilac terrestrial herb called Dactylorhiza hatagirea. Locally, it's known by a few names, like Panchaule or salep. It's totally endemic, meaning it's uniquely adapted to this highly specific mountainous stretch across India, Nepal, Pakistan, Bhutan, and China. Above ground, it's this stunning addition to the high-altitude flora. But its true value, and honestly, its curse, lies hidden beneath the soil.
And this perfectly illustrates the tragic irony of the plant. The contrast is wild. Those stunning flower clusters above ground, illegal hunters completely bypass them. They don't care about the flowers at all. They're only after the hand-shaped, palmately divided, water-storing tuberous roots hidden below. Now, the plant evolved these tubers simply to survive the freezing, arid conditions of the Himalayas. But, well, humans found a completely different use for them.
Because those hidden tubers, they are an absolute chemical goldmine in traditional Indian medicine systems. We're talking heavy utilization in Ayurveda, Unani, and Siddha. The root powder and decoctions are used to cure almost everything, from severe wounds and gastrointestinal infections like dysentery to acting as a nervine tonic for general debility. Plus, it's incredibly sought after as a restorative tonic and a super potent aphrodisiac, traditionally believed to cure sexual dysfunction and massively boost vitality.
Which brings us to a critical breaking point. Section 2. A species on the brink due to overexploitation. The crucial point here is that this immense, centuries-old medicinal value has placed a huge, completely unsustainable target on the orchid's back. When ancient remedies meet modern global demand, the math rarely works out in favor of nature. 5,000 tons. That is the staggering estimated annual demand for this single species. It's a completely overwhelming volume that wild populations simply cannot support. We're seeing total overexploitation, which has caused it to be listed as critically endangered in the Indian Red Data Book. To put that 5,000-ton demand into a more, well, gruesome perspective, you have to exploit and kill 90 to 100 mature plants just to produce 1 single kilogram of dried roots. Because the root is the prize, harvesting it means utterly destroying the plant. Actually, scratch that. It's not even just harvesting, it's total removal. There's no trimming or pruning involved here.
Now, you might be wondering, hasn't the government stepped in? They have. The rhizome is strictly banned from collection and trade. Legal, authorized collection carries a royalty fine of 500 rupees per piece. But here's the harsh economic reality. Local inhabitants, who are driven by huge market demand, illegally harvest and sell these roots for a mere 100 to 200 rupees per kilogram. That's just a tiny fraction of the penalty cost. The economic incentive to poach completely overrides the legal deterrent, driving the species toward rapid extinction. Entire areas that once saw abundant blooms are now practically barren.
All right, Section 3, the orchid's chemistry at a molecular level. Let's look under the hood and see why modern science desperately needs to solve this.
If we're going to save it, we need to understand what makes it biologically tick. At a molecular level, this plant is packed with complex carbohydrates, mucilage, and distinct lipids. Take Dactylose A, for instance, which is one of the major, completely unique constituents of the tuber. This isn't just folklore, you know? There is intense, highly complex biochemistry happening right inside these roots.
These specific phytobioactive compounds, namely dactylorphins and dactylosis, give the plant a really remarkable ability to fight off dangerous bacteria. What's absolutely fascinating is that studies show these rhizome extracts exhibit strong antimicrobial resistance against both gram-positive and gram-negative bacteria. That essentially covers the vast majority of bacterial threats out there. Most notably, they are highly effective against E. coli, even the strains that have become super resistant to our synthetic drugs. So it absolutely proves that the ancient folkloric uses for treating things like dysentery have serious, quantifiable scientific merit. Moving on to Section 4, the conservation challenge and why traditional efforts are failing.
With such vital chemistry at risk of being lost forever, we really have to look at why standard conservation just isn't working here. Why can't we just protect the land or, I don't know, plant more seeds? Well, the problem is kind of twofold. In situ conservation, meaning wild protection, requires a highly disciplined 4 to 5 year harvesting rotation, making sure to deliberately leave immature tubers behind. Poachers, for obvious reasons, simply don't follow those rules. On the flip side, ex situ conservation, trying to grow them in traditional soil nurseries, is just vastly outpaced by the illegal harvesting. Plus, their natural habitats are constantly being destroyed by local livestock that overgraze and trample the fragile underground shoots.
But honestly, the fatal biological flaw comes from the orchid itself. An orchid capsule drops millions of microscopic, dusty seeds. But these seeds lack an endosperm, meaning they literally have zero built-in food reserves. To grow, they strictly require an interaction with a very specific symbiotic mycorrhizal fungus in the soil. Without that exact fungus, the seed just dies. And that brings us right back to the beginning. This is exactly why the wild germination rate is that catastrophic 0.2% we talked about earlier. Nature has just made it incredibly difficult for this plant to bounce back on its own.
Which leads us to some much-needed good news in Section 5, saving it with science through a biotech rescue mission.
Fortunately, we don't have to rely entirely on nature's strict limitations anymore. Researchers from the JP University of Information Technology stepped in and found a way to completely bypass these biological hurdles using advanced biotechnology. Instead of waiting around for those vulnerable, needy seeds, the scientists basically hacked the growth cycle using a process called tissue culture. Step 1 involved taking tiny, field-grown microshoots from the plant. Step 2, they perfectly sterilize these explants to remove any contamination and pop them not into soil, but into highly controlled liquid plant incubators using a nutrient broth known as MS media. And for Step 3, they stimulated mass multiplication by tweaking the exact chemical recipe of plant growth hormones.
And wow, the resulting breakthrough is crystal clear. By optimizing this liquid broth, specifically utilizing a precise cocktail of plant growth hormones known as BAP and IBA, they achieved an explosive maximum biomass yield of 6.29. This liquid environment, when compared to standard solid agar media, allowed for incredibly rapid mass multiplication of both shoots and roots. They essentially engineered an optimal, hyper-efficient artificial womb for the orchid.
But, growing a plant in a sterile lab beaker is really only half the battle. Can it survive the real world? Well, the most incredible part of this research is that when these lab-grown plantlets were finally transferred out of the liquid media and into a simple greenhouse potting mix of cocoa peat, vermiculite, and perlite, every single one of them survived. A 100% survival rate after a month of acclimatization. They literally cracked the code for the large-scale commercial production of a critically endangered species.
So as we wrap up this explainer, we are left with a pretty profound question. We have a plant pushed to the absolute brink of extinction by human greed, coupled with an incredibly fragile natural biology. Yet, human ingenuity stepped up and managed to hack its growth cycle, completely eliminating its reliance on a 0.2% wild chance. If we're going to save the ancient medicinal wonders of our natural world from exploitation, is our best and maybe only hope found inside a laboratory beaker? It's a genuinely fascinating intersection of nature and technology. Thank you so much for joining me on this explainer, and I hope this changes the way you look at the incredible plants quietly surviving in the wild.